Okay, so let's discuss about the final and the conclusion part regarding the databases, that is choosing the right database, right? So here till now we discussed about the SQL databases, its properties, and we looked into different non-SQL databases, right? So we understood about the properties and different types of databases. Now it's a time to understand or to define couple of things that will help us to choose the right database at the end, right? So for that reason, here what I have listed down these 8 critical questions that we must ask before finalizing any database. Okay, so for that, first of all, we should understand these 4 different types of data. That is, first is structured data. So structured data is when we know exactly what data we need to store. Like for example, where we have a defined parameters, and every data that will be added will have the same parameters. In such condition, we can call it as structured data. For example, the transactions in the banking scenario, where every transaction will have a transaction ID, customer ID, amount, date, and status, right? So this kind of data we can call it as a structured data. Then we have a semi-structured data like the product catalog, where every product will have couple of things that are same, but couple of things that will different, right? Or that may vary. For example, if the product is a t-shirt, then definitely it will have a product ID and name and the price. But if we compare that with mobile, then they have some different parameters. Like the mobile will also have a product ID, name, and price, but the mobile will have processor and RAM, but the t-shirt will not have that. So here this data is semi-structured. So this is another kind of data. Then we have a couple of unstructured data like images, videos, or the file systems, where we have PDFs, documents, right? So these data we can call it as unstructured data. Okay, and then we have another set of data where we store them in the form of nodes and pointers, right? Which we discussed while discussing the Neo4j database, right? So that's another kind of data. And then we have key value pair, which we also discussed earlier. That's another form of data. So we have these kind of broad category of data. Okay, so this is the first criteria that we should define for our data, like under which category that data will fall. Okay, so now once we are final with the category of the data, like whether it is structured, semi-structured, or unstructured, then we can move on to the other questions. Why we need to move on to other questions when we have already finalized the structure? Because if it is a structured data, then definitely you may think that we should go with the SQL kind of databases, right? But sometimes even when the data is structured, we may not need the strong consistency or isolation, or we strongly need the high scalability, right? In such condition, we may tend towards the non-SQL databases like MongoDB. Okay, so this can be like to handle this kind of scenarios or conditions, we should answer the other questions as well. Okay, so we are good with the first question, but we need to look into the other critical 7 questions, right? Due to that reason, here I have created a separate Excel sheet where I have defined all those 8 questions. And I have added the different databases that we can consider. So here the process is, first of all, we will define what is the data we are trying to store, and then we'll try to answer all these questions by adding a score to each databases. Okay, so let me start by from the first question, and you will get to understand what we are doing here. So here basically we will add the score on the basis of 0 to 2, where if the score is 0, then we will it's not possible kind of thing, where this database will not help us to solve that problem. If it is 1, then that means it's a 50-50 where it can help, and there are other options also which can help us to do the same. And if the score is 2, then that means this is a strongest favor, like this database that will help us to implement that thing in a most efficient or the high performance manner. Okay, so here let's first define the data type or the data that we are going to store. So here let's take the example of the bank transactions. So you can perform the similar set of activity for the other data types also. Okay, so let's say we are trying to store the bank transactions. Okay, now here if we are trying to store the bank transaction like this, where we need to store the transaction ID, customer ID, amount, date and status. Now considering that, so the first question here is, what type of data am I storing? So here definitely it's a structured type of data. So as we discussed, if the data is of structured type, then definitely MySQL will help in a strongest manner. So we can give a score as 2. Whether MongoDB will also help us to store structured data, definitely it will help us to store the data in the same manner. So we can give it as 2. What about Redis database? Whether Redis database will help us to store the data if it is structured, then definitely it will help, but it's not as good as the other two databases. So that's the reason we can give it as 1. So whether Neo4j will help, then definitely it will also help us to store the structured data, because here also we are storing the data in the form of objects, but on top of that we are going to create the connections. So here we are not worried about the connections, only are worried about whether we are able to store the structured data or not. Yes, then definitely we can store, so we can give it as 2. Okay, now coming to the next question, that is how does the data relate to each other? Now comparing to the bank transactions, considering this, as we know, every transaction has a customer ID, right? So what does this define? So here this customer ID is a foreign key in the transaction table, where we are referring to the another table's column. So with the help of customer ID, we can able to know about the customer from the customer table, right? So here we have a strong relationship getting formed between the tables. So in this case, which database will provide us to implement this? Then definitely it's a MySQL or a SQL database that will help us to do that in a more efficient and a proper manner. What about MongoDB? So in the MongoDB, it's not that efficient or properly we can define the relationships. So though we can add another semi-object within the same document, but that's not a preferred way, but we can do it. So that's the reason we can just give the score as 1. Then what about Redis? Then Redis will definitely help us to do as like Mongo, where we can add within one object, but that's not an ideal way. So that's the reason we can give it as 1. Whether Neo4j will help us to do that? Yes, definitely we can add the data, create the relationship, but that's not an efficient way. So that's the reason we can just give it as 1. So giving the score as 1, that means it's possible, but that's not recommended, or we should go with that. So that's the reason I'm giving it as 1. Okay, so we'll give it as 0 only when if it is not possible. Okay, now coming to the next thing, that is how often will the data be the read, whether it is a read or write kind of data. So considering bank transactions, it's a highly write kind of data, where the writes will be more than the reads. So considering that, then definitely MySQL will help us with that. There is no issue with the reads or writes. Okay, now what about Mongo? Mongo will also definitely help us. Redis will also definitely help us. Neo4j will also definitely help us. So there is no much difference between the reads and the writes. But yeah, considering the reads, here the most efficient will be the Redis, because here the data will be stored in the memory of the RAM. So the reads will be more efficient. But in a overall, but here we are more worried or concerned about the banking transactions or bank transaction data. So for that reason, we are given SQL as 2. Okay, so here for this condition, all the database will score the same. Now here I may have a bit different opinion, or you may have different opinion or agreements when compared to my analysis. So that's totally fine. Okay, so you can have different scores according to your analysis, but I'm just adding it according to mine. Now considering next regarding the ACID properties. So as we definitely know, there is no other database that provides this as strong as SQL databases. So SQL definitely have a 2, And considering the banking transactions, we need a very strong consistency and isolation, and that will be provided by the MySQL. What about Mongo? Mongo will not have a strong consistency, which it's basically gives us an eventual consistency. So that's the reason we can give it as 1. Then compared to Redis, then Redis will not promise us the ACID properties, so that's the reason we need to give it as 1. Neo4j does not promise us ACID properties, so that's the reason we can give it as 1. Next, about the high scalability and flexibility. So whether MySQL gives me high scalability and flexibility, both no compared to the other databases. For that reason, I will be giving it as 1, because here the schema has to be defined at once. We can though change the schema later on, but it's not as efficient as compared to the other databases. What about MongoDB? So MongoDB gives us both the things very efficiently, so that's the reason we can score it as give the score as 2. What about Redis? So Redis also gives us both. We can have flexible schema and high scalability, definitely, so that's the reason we can give it as 2. Neo4j, like MySQL, we can give it as 1. Next is querying mostly a key based, a document based, or relationship based. So here it's a relationship based, so definitely that will help us. That's the reason I can give it as 2. And here the MongoDB will help us in the same manner, but comparing to the transactions where it is highly relationship based, going with MongoDB is not a preferable way. That's the reason I'm giving it as 1. And same reason for Redis also, and the same reason is for Neo4j also. Okay, so Neo4j also gives us this relationship, like we can store complex relationship, but that relationship is different compared to the relationship that we are talking about in case of banking transactions, right? So that's the reason I'm giving Neo4j as 1. Next, do I need low latency caching or high speed lookups? No. So this is not the need for the banking transactions, right? So that's the reason here I will give this MySQL as 1, because that it does not give or promises this very efficiently, because other databases has this feature in a more enhanced manner, where, for example, MongoDB also does not helps us with the low latency or high speed lookups, and comparing to the bank transaction, this is not the ideal one. So that's the reason I'm giving it as 1. If only this was the criteria, then definitely Redis would have given me these features. So that's the reason I'm giving it as 2. And Neo4j also same, I'm giving it as 1. Next, coming to the how important is analytics or real-time interaction. So regarding banking transactions, it is highly real-time, right? So it's a live transactions we are dealing with. So that's the reason here whether MySQL provides us with this feature, yes, definitely it will help us with dealing with the live transactions with a strong ACID properties. So that's the reason I am giving it as 2. What about MongoDB? Yes, definitely it will help us with the analytics kind of data. For the live interaction with the database, like considering the ACID properties, MongoDB doesn't give it. So for banking transactions, it's a real-time interaction. So that's the reason I'm giving MongoDB as 1. If it would have in any analytics kind of data, then definitely we would have given MongoDB as 2. Then Redis, compared to the real-time interaction, here if it is a caching, then definitely it would have been 2. But now it's about storing the transaction, so that is the reason I'm giving it as 1. Same with for the Neo4j. Okay, so now at the end we have a rough scoring for all the databases, and here definitely it's just my one person analysis. So here when we will be doing this operation for a bigger purpose or a bigger organization, then definitely there will be multiple stakeholders or the people who will be defining this. So then we'll have a stronger scoring or scoring done after a strong reasoning. Okay, so with this, if we look at, definitely MySQL will be the winner with the score as 14. MongoDB will have a score of 11. Redis will have a score of 11, and Neo4j also has 10. Okay, So considering that, definitely MySQL wins here, and we can definitely go with MySQL for banking kind of transactions. But if we are considering some other kind of data, then for that we should do this activity again and check the score, and then on that basis we can finally go with any one kind of the database. Okay, so I hope you were able to understand this activity or the concept, like how should we finally go with any database. So it should be always on the basis of some analysis. Okay, so definitely there may be some other questions that can be added to this list for a final decision. Okay, so I hope overall you got to understand about this process of choosing the right database.